All right, question number 6. We want to determine the intervals on which the following function is continuous. So this is just a review question from chapter 6. Chapter 2. So we have the function f of x and x minus 10 divided by x squared minus 100. So this problem is just basically checking the domain of the function. Since we have a rational function, we want to set the denominator equal to 0 and find out what makes the denominator 0. Those points will be removed from the domain, and then we will be able to find the intervals of continuity. So we want to find those intervals. So I'm going to just focus on the denominator. We're going to take x squared minus 100, set it equal to 0. Now we can either move the 100 over and take the square root, or we can factor this. We can do difference of squares, factoring here, so that will give us x plus 10 and x minus 10. Okay. You could also, add the 100 and you would have x squared equals 100. And then you would solve this by taking the square root of both sides. When you take the square root of a number, you have to remember plus or minus. So we get x cannot be equal to positive or negative 10. Same thing here. When you set both of these equal to 0, x plus 10 equals 0 and x minus 10 equals 0. Solving for x, we get x equals negative 10 and we get x equals positive 10. So talking about a domain, we cannot use these numbers because they cause the denominator to equal 0. So if this is 0, we would have a negative 10 here, and this is going to negative infinity. This is positive infinity. We would remove this point, there would be a hole. And at positive 10, we would remove this point, there would be a hole. And so we would go from negative infinity to negative 10, and then there would be a break. We would connect the other side of negative 10 up to positive 10. Then there would be a break, a little hole here, and we go to the other side of positive 10 up to infinity. So we got 3 intervals of continuity: negative infinity to 10 to negative 10, and then negative 10 to positive 10, and then 10 to positive infinity. So we're going to come here. Let's see, maybe they want us to use this symbolic. I'm going to say negative infinity to negative 10. Do we have our union symbol? I think we want to use the union. Negative 10 to 10. And then our last part, to infinity. Okay, so it says that is incorrect. Let me see, determine the following. Use a comma to separate answers. So maybe they don't want the union, we'll just separate them with a comma. Okay, so sometimes they want the union, but just be sure to read what they want. They just wanted the comma this time. All right, problem number 7, we have 4 parts. It wants us to use the graph, identify points on the interval AB at which local and absolute extreme value occurs. So again, we're looking for local and extreme values. I'll blow this up a little bit. So we have the absolute minimum value at A. It looks like a break, but we could call this like a div. It looks like it just kind of like changes direction, but I'm assuming they won't disconnect it. So we have a low point at A, absolute highest point at B, a local maximum at Q, and a local minimum because it goes from decreasing to increasing at R, local minimum. So we got one of each. So we have a local minimum at R. This one wants us to select the maximum, the local maximum, local high point, mountaintop at Q. Those are always going to be interior. Local points are always going to be on the inside. So that's going to be at Q. Sorry. I went to next instead of check. All right, this one wants us to find the absolute minimum that would occur at A, the absolute lowest point. And then the absolute maximum, the absolute highest point occurred at B, higher than any other point on the graph.